Okay, some fundamental identities. So what's listed out here is we have a couple quotient identities, right? Rewriting tangent as sine over cosine, or cotangent as cosine over sine. These are quotient identities, whereas these others, secant is 1 over cosine. That is a reciprocal identity, as well as these other ones. Cosecant is 1 over sine, cotangent is 1 over tangent. Let's see if we can utilize these to evaluate tangent of 45 degrees. When we're given sine of 45 and cosine of 45. So to get tangent of 45, what I'm going to use is this quotient identity. So I can first rewrite tangent of 45 degrees is going to equal sine of 45 over cosine of 45 degrees. All right, now that I've replaced those using our quotient identity, what I can do next is I can start filling in that I know that sine of 45 degrees is defined to be the square root of 2 over 2, and that cosine of 45 degrees is also the square root of 2 over 2. So what we're going to do on this is simply replace those with square root of 2 over 2 for sine of 45 degrees, and then cosine of 45 degrees, again, it's kind of a fill-in square root of 2 over 2. So from here, we end up with the same thing in the numerator as we have in the denominator. That should simplify down and equal a 1. So our solution here, tangent of 45 degrees is going to be 1. Next, let's see if we can use these identities and evaluate secant of 5 pi over 6. So we're given sine of 5 pi over 6 is 1/2, and cosine of 5 pi over 6 is negative square root of 3 over 2. So to get secant of 5 pi over 6, what I'm going to do is I'm going to utilize this reciprocal identity that we can connect together. Secant is 1 over cosine. So I'm going to rewrite this as 1 over cosine, 1 divided by cosine of 5 pi over 6. And then we can replace in that we know that cosine of 5 pi over 6 is negative square root of 3 over 2. So I'm going to fill in, I've got 1 divided by the negative square root of 3 over 2. All right, from here, it's a little bit of simplifying down that we have a fraction within a fraction. We usually don't like to leave our solutions like that. So what I'm going to do is I'm going to first multiply numerator and denominator, each by 2. This will eliminate our fraction within the fraction, because when we multiply our denominator by 2, we have 2 times 1 over 2. These get to create a 1 as we simplify this down. So I'm going to bring the negative out in front. In the numerator, I have 1 times 2. So I'll have a 2 up there. And the denominator, as we cancel out those 2's, they make a 1. We're going to be left with a square root of 3 in our denominator. It's probably going to be a little bit better answer if we can rationalize this denominator by getting rid of the square root. So what I'm going to do is multiply numerator and denominator each by the square root of 3. All right, in doing so, we can multiply our numerators. So we have 2 times the square root of 3. And I'm going to go ahead and bring that negative along. So negative 2 times the square root of 3 over, in our denominator, we have square root of 3 times square root of 3, which works out to be square root of 9, or that simplifies down to simply being 3. All right, hope this helps out as you're working with these fundamental identities, getting down the quotient identities and the reciprocal identities. They're not that bad, but it takes a little bit of practice to get comfortable with them. Good luck.